Now, one thing that we have to note when we're drawing in one-point perspective is that it only works if the basic box is facing us at a 90-degree angle. So what does that mean? Let's say I'm going to be drawing here an isometric grid. And let's say that you, the viewer, are here and you're looking in this direction. So when we're drawing in one-point perspective, it's important that the basic box that we will be slicing for our objects, one side has to be facing us, the viewer, at a 90-degree angle. So it can be as wide or as narrow as you want, but what's required in one-point perspective is that, again, the one side is facing us at 90 degrees. If you have a box that's at an angle like this, this cannot be drawn in one-point perspective. You would have to use two-point perspective, which we will be talking about in another lesson. So if you will be drawing a one-point perspective scene, then like isometric drawing, you would have to set up the space where you will be placing your basic boxes and slicing them. So essentially, this is what you will be drawing for to set up the space. So it's essentially a box that's facing us, and you have all these grid lines going around to help you in the construction of whatever object you want to place inside that box. So to do that, I have here my drawing surface. So it can be your large size sketchpad, or it can be bond paper, but it would be nice if you drew your perspective plates in as large a sheet as possible, so that when you start adding those objects, then especially the details, you will have an easier time. So let's set up the space. I'm going to start doing the horizontal or the horizon line right here, smack in the middle, going across. Now, the horizontal line, you would want to place it right here in the middle, but sometimes you might want to place it slightly higher if your emphasis is the objects underneath, or you might place the horizon line a little lower if you want to emphasize more what's going on top. But generally, the horizon line, since it is eye level, we usually place it in the middle of the sheet. Then we will establish our center vanishing point. The next thing you're going to do is you're going to measure. So I'm going to measure from the center vanishing point going up just enough so that I have a lot of space to work with. So I'm going for 3 inches right here. In your case, it will depend on how large your drawing surface is. Let's see if I can do, okay, I can do 9 centimeters right here. So at least I have this white border, and then I have 9 right there, and then I'm going to go 9 underneath. So this should be straight through the center vanishing point. So since I have 9 here and 9 here, I'm now going to go for 9 on one side and 9 on the other side. And I'll be doing the same all around. So once you have your box, it would be great if you double check just to make sure you have all your measurements as close to accurate as possible. So in this case, it looks pretty good. The next thing we're going to do is we're going to X this out. So now, essentially here, this large box represents the front of the box that's facing us. So since this is the front, then we establish the back. Now, how large the back will be depends on you. You might want to have a little space here at the bottom because it's in this area where the ground plane is. So you might want to have a little bit of space here so that when we add the grid boxes for the ground, you have enough space to work with. So I'm just going to go maybe around here. And then I'm just going to insert, bring that around. So a little miscalculation there, but you get the general idea. So again, we have this large square as the front of the box, and this represents the back of the box. It's smaller because in 1-point perspective, things get smaller as we approach the horizon line. So now that we have this front, the back, this is now the ground plane. This is the side, one side, this is the other side, and this is the top. So you can imagine this is some kind of a squarish room where you'll be placing stuff inside. So let's assume that we're working with a grid of 4x4. 4x4 meters. So generally when we're working with perspective grids, we're using squares of the same size. So a 4x4 grid, we're now going to translate that 4x4 grid into this bottom space. So there are several ways to do that, but so I'm just going to do one way. In the back or in the front, I'm going to start with the front. I'm going to divide this now into 2 equal parts. So if this is 9, then that's a 4.5, and divide this as well into a 4.5. So now that I have 2 points in there, I can now use my center vanishing point and bring this towards the back wall. I'm not going to go all the way so that we minimize the number of lines that we're making. Same thing with this one. Bring this over to the back wall, and there we now have the first 4 right there. So now how do we do the horizontals? What we're going to do is we're going to take one corner and bring it up to the other corner. So essentially we're taking this corner all the way over there. So from this corner to this. And now these intersections are essentially these intersections. So now you can draw your lines across, and you will have your ground plane. So just make sure that it's as horizontal as you can make them. So now you have the ground plane. You will do the same process for the rest. So I'm going to do that right now. Now, when it comes to establishing the grid, you can do the horizontal, the diagonal lines from corner to corner, or you can, since we already have these in place, we can go take those vertices and bring them up, making sure that your lines are really vertical. Okay, so you can do that. Again, you can do the diagonal line. And then you have these intersections. And you will see that they're supposed to align here. And we'll seal this off at the top. Of course, you will be doing this in very light lines because you don't want to have too many lines on your paper. I said visible lines on your paper. And then the last thing we're going to do is we're going to do the back wall. So since we have all of these points in place, then we can just take each and connect those vertices vertically and horizontally. So now here we have our 1-point perspective space, wherein we have the ground, we have the right wall, the left wall, and what can be a ceiling. So why would you need to establish this grid? So like what we did in 3D drawing, you would need a grid to establish proportions and measurements. So if we establish that 1 unit of this is 1 meter, let's say this is 1 meter, then all of these individual segments will be 1 meter. Whether they're close to you or further away from you, all of these will be 1 meter. And why is that important? Because you're now able to ensure that when you place objects in your space, their proportions will be more or less, they're proportionate. So, for example, if we look at, let's say, a chair, and a chair would have a seat height of 0.5. So I'm just going to draw that side view of that chair. Let's say you want to make that chair, which is 1 meter high, and this is 0.5 meters, and this is 0.5 meters. Then it's a matter of building that box. So I can place that box, let's say here. I'm going to place the chair against the wall. So I just need a 0.5. So in isometric, this is 1, this is 0.5, this is 0.5. So in order to position this in a 1 meter square, I need to divide this. We need to X that out. So I'm going to X that out first. Let's say I'm placing it in this grid square. So this is the center of this grid square. And I know, based on the scales that we've established, that this square is 0.5 by 0.5, which is essentially the bottom of our chair. Then we can build that up. From this corner, we move up to 1 meter. So that's 1 meter right there. And then we can complete that box from this corner, which is like this far end, go up, and then use that perspective projection. So now we have this, which is the back of the chair. To get to 0.5, for the height of the chair, we can X this out to find the middle part, or since we know that this is 1 meter, we can just half that to get 0.5. And that's the seat height. And we can just continue building that by connecting things in using the principles we've talked about in 1-point perspective. So now I have the chair right here in 1-point perspective. So if you want to place another chair facing us in this far corner, then you will do the same process. I'm going to X out that grid box, knowing that this intersection is like 0.5 meters in. And let's say I want to place the chair facing us right here. So I'm going to find that little square right there. The chair is 1 meter high, so we'll bring that up to 1 meter. And then find 1/2. This is 1 meter. So half of that, that's the seat height. And then use perspective projections to find that. And this is now the chair. So these two chairs are the same size, of the same dimensions, but we place them in 1-point perspective. So the last thing we're going to do for this space is I'm going to place a large bookshelf in the back wall, because a lot of students have difficulty, especially when it comes to the shelves. Now, let's say that we want our shelf to be, again, 0.5 meters in thickness. So I X'd out this grid square just to find 0.5 meters. And then I'm going to establish this. So I want my bookshelf to be against this wall, but it's facing us. And maybe the length, I want that bookshelf to be until there. So I'm following that vanishing point for this. So this space now will be where my bookshelf will be. I'm going to bring this up. Let's say I want my bookshelf to be like 3 meters high. So that's the 3 meter mark. And then I'm going to seal that off with a perspective projection. Then from this point, we'll take it to the other side. And since our shelf is against this wall, I'm going to use this point and use that to find that intersection over here and bring it down. So let me darken that up for you so that you can see what's going on. So now we have our basic box for the shelves. So to simplify things, let's say I just want to have this one big area for the first shelf. So I'm just going to bring that in, this thickness in, so that our shelves have some kind of a volume to it. So I'm marking out my first shelf. So when you're making shelves like these, you need to establish again what the front looks like in terms of this thickness for the shelf. Because once we get inside the shelf, this is where a lot of students stumble. Because what they do is, because they feel that inside the shelf has to have some thickness, they would really go super far or at a wrong angle. They're not following the vanishing point. In this case, you would need to follow the vanishing point. So the corner where we establish the opening, that corner right there, that's where that line will be. So how deep should it go? Well, we already have a reference. This is in this side wall, this is the limit of that side wall. So you can now eyeball that. You just want it to be a little more in. And that's what it's supposed to look like. So I'm just going to shadow underneath that top. Another mistake that students make is, because they want to do a shelf and it's straddling on the horizontal line, I'm just going to make another opening right here. For example, we have another opening of the shelf right here. What other students do is that because they did this for the top, they assume that they will also do the same here at the bottom, which should not be, because this opening is below the horizon line. We need to follow that vanishing point. So we don't see underneath this, rather we see this part. And whatever thickness you placed here, that's going to be the thickness there. So that's now what that bottom shelf is supposed to look like. And then now you can place your books, you can place your vases. Now, when your items are really this small, you can afford not to really go heavy into the 1-point perspective thing, unless of course maybe you have a stack of books right here. Let's say you have a stack of books, then definitely you would need to follow that 1-point perspective vanishing point in order to place the depth of those books. So again, when you want to place objects in your 1-point perspective space or any other perspective space, you need to know exactly how big each item is relative to each other, because you will be using those grid lines to ensure that every object is of the size that you want relative to the other objects, and you won't end up with an odd result. So I need to follow up this video with one more thing. What if you want to place an object in an odd position on the ground plane? So one example is, let's say you want to place a person, and we want to place the person, for example, in this grid, and the person is facing us and he is right here, somewhere in the middle of this grid square. What if this person is, let's say, 1.75 meters tall? Okay, so in order to do that, we have to find 1.75 meters here. Since the person is standing right here, then the first thing we have to do is to find that height, 1.75. We cannot just place 1.75 meters here because the person is not standing here. The person is standing a little further back, which means this measurement of 1.75 will not apply. So we need to do some projections. Starting from this, where the character is standing, draw a line towards the corner, bring it up. So this is where that character is aligned. And then we can get 1.75 meters from here and connect that with our center vanishing point. So this intersection right here, that's where the height of that character is. So you'll see that there's not much of a difference between these two, but you need to understand how this works because you might be dealing with an object or a character that's of like an unusual height. So you need to know this system. Again, if the character is standing here, just bring a horizontal line to our corner, bring it up, and then find that 1.75 meters here, and then do that perspective projection from your center vanishing point. Then from that vertex, do the horizontal line, and that's where our character will be standing. And again, because this is 1-point perspective, we will express the position of that character in a box. So the character will be in a container, which will help determine all those or how that character will be oriented. So this will work if the character is facing us directly or if the character is in side view. Okay? Let's have another example. Let's say that there's another character, let's say right here. So let's assume as well that the character's height is maybe 3.5 meters. Let's make him like over 10 feet tall. So here's where that character is standing. So we find that point, go to the wall, the corner of the wall, and then bring a vertical line up. Find 3.5 meters, 1, 2, 3.5. Bring it now to the center vanishing point. Find that intersection. And then do that horizontal line. And this is now the height of our 3.5 meter tall character standing in this grid square. Lastly, take note that because the head of the character is above the horizon line, remember that when we do the head, right there in the middle is a sphere, is an ellipse where you have the eyes. So in this case, if we have the sphere right there, then, and it's above the horizon line, then we see our sphere this way. It is not straight ahead, it's more up because it is above the horizon line. Your square essentially looks like that. So for this character, the eye line would be more arched this way. For this character, since he's below the horizon line, then it's a little more down. Not completely down, it's almost straight, but there's a slight curve in there. And there you go.